Okay, good morning everybody. This is Mr. Goh here, and today we'll be going through the different factors that affect temperature. Last week we have already went through certain how to calculate temperature and its different types of readings. Today we'll be looking at specific factors and how it affects temperature to quite a large degree. First things first, we'll look at how does the altitude affect the temperature of locations. Now, what does altitude mean? Altitude is the height of a place in relation to the sea level. Most of Singapore is at 0 meters sea level or 0 meters altitude. This is called sea level. In fact, can you guess the highest point of Singapore? Okay, the highest point in Singapore is actually only 164 meters high, and that is actually Bukit Timah Hill. And what you notice is this: as we move up every 1000 meters in height, which is 1 kilometer in height, the temperature will drop by 6.5 degrees Celsius. And that is why places like Genting Highlands, Cameron Highlands are noticeably colder compared to the bottom of the mountain when you compare the bottom of the mountain and the top of the mountain. In fact, that is why you will notice at most of the mountain tops such as Mount Everest, you'll notice a large amount of snow. That is why it's white in color, because of the fact that it is so cold up there at 3,000, 4,000, 5,000 degrees, 5,000 meters up high. What you notice is this: altitude, height of a place in relation to the sea level, and the point is temperature is higher at lower altitude while temperature is lower at higher altitude. So this is called an inverse relationship. First explanation why. The first explanation is this: the solar energy from the sun reaches the surface of the earth in the form of short-wave radiation, as you can see over here. Now, as the earth itself absorbs some of this short-wave radiation, it will then emit it in the form of long-wave radiation, as you see over here. Now, as this long-wave radiation comes out, it will heat up the areas nearby. And what will happen is the further up you go, the higher the altitude, the lower the temperature as it is further away from the surface of the earth. So over here, it will be much cooler compared to over here, where it will be much colder, hotter. So you can see over here, hot. At the top, it will be cold. Okay, so the higher the altitude, the lower the temperature. It's further away from the surface of the earth, which is emitting long wave radiation. Now, second part is this. You can see over here as well, incoming short wave radiation coming in over here. Some of it will be absorbed by the atmosphere, some of it will be absorbed by the earth's surface, but more importantly, some of it will become outgoing long wave radiation. Now, second explanation is this. We have this thing called the greenhouse effect. Now, many of you would have heard about the greenhouse effect when you're looking at documentaries about looking at climate change. Now, the greenhouse effect actually is something very important for us to know, and also it's very important for this earth to remain hot enough for us humans to survive. Now, what happens is this: the long wave radiation emitted by the earth is absorbed by greenhouse gases and warms up the earth. The air nearer to the surface of the earth will absorb more heat, hence the higher the altitude, lower the temperature. Reason why is very simple. Over here you can see a diagram called the natural greenhouse effect. What happens is the solar radiation comes in. What happens is the air around or near the atmosphere will absorb the heat, and as it absorbs the heat, it carries on heating up the earth, causing temperature to be hotter. Now, the higher the altitude, the lower the temperature, because as we look further, the higher the altitude, we have less greenhouse gases and less ability to absorb heat. That is why the higher the altitude, the lower the temperature. Now, this brings me to point number 3. Point number 3 clearly states air is less dense at higher altitudes. Dense air is able to absorb more heat from long-wave radiation from the Earth's surface, hence the higher the altitude, the lower the temperature. What you notice over here is that at sea level, compared to 14 feet above sea level, which is about 10 plus kilometers above sea level. Now, which one has larger amount of air particles, which is represented by the green and the blue? Could you tell me right now which one? Okay, that's right. At sea level, you'll notice there are much more air particles at sea level compared to 14 feet above sea level. Now, what does that mean? It means this. At sea level itself, all these air particles actually absorb heat from the Earth's surface. So what happens as it absorbs more heat, it remains hotter at Earth's surface compared to if we move further away, further up, you'll notice that at 14 feet above sea level, there are much less, gas particles, hence the higher the altitude, the lower the temperature.